In these exercises, we're doing the same thing, but now they're equations, so we will have to solve for the variables. In this first example, we have x to the third minus 8 equals 0, and so we will factor it first. We have an x and a 2, an x squared and a 4 as our outside terms, and then the product of 2x in the middle of the trinomial. For our signs, it will be minus, plus, plus, and this is always set equal to 0. Once we have factored it, we set our factors equal to 0. And our solution for at least one of them is x minus 2 equals 0, so x equals 2. For this other one, we're going to need the quadratic formula, and that we will talk about in just a minute. This next one is 64x to the third plus 27 equals 0, so the cube root of 64 is 4. Cube root of x cubed is x, cube root of 27 is 3, and we'll do plus for our sign, and then opposite and always positive for the other two signs in the trinomial. We'll square 4x and we'll get 16x squared. We will square 3 to get 9, and then we'll take the product to get the middle term, which will be 12x. Don't forget to set these equal to 0. Now we need to set each factor equal to 0. This gives me x is equal to negative 3/4. The other trinomial, 16x squared minus 12x plus 9, is also equal to 0, but we need more information to solve those. Since they're trinomials and they don't have obvious factors, we are going to need to use the quadratic formula. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This will be helpful when you have a trinomial that does not have nice factors. And in this case, if you were to graph any of these difference of cubes that I'm showing you, or sums of cubes that I'm showing you, you'll find that they only have one solution, in which case the rest of the solutions are not visible on our current number line. We would have to look at a complex number line to find them. These exist, but just not in your calculator, and so I'm going to show you how to find those complex numbers. When using the quadratic formula, it's helpful to remember the coefficients and what they represent in the formula. We have a, b, and c representing in the first exercise or equation 1, 2, and 4 respectively. In the second equation, we have a equals 16, b equals negative 12, and c equals 9. When we're using the quadratic formula, we have to remember which number represents which piece of the quadratic equation. Now I'm going to substitute them in. So x is equal to negative b, so the opposite of b is negative 2, plus or minus the square root of b squared, so positive 2 squared, minus 4 times a, which is 1, times c, which is 4, all over 2 times a, which is 1. We can simplify this. This will be negative 2 plus or minus the square root of 4 minus 16 all over 2. Notice that 4 minus 16 will provide a negative 12 inside the radical. So we will get a negative 2 plus or minus the square root of negative 12 all over 2. We need to pause for a minute because a negative 12 is also equal to negative 1 times 4 times 3. The 4 is a perfect square, which is convenient because we can bring that outside the radical. The remaining digits, well, we have a negative 1. Now remember, from up here, I is a complex number. When you have a complex number, it's on a separate Cartesian, it's separate from the Cartesian plane. So we will have negative 2 plus or minus 2, that's coming from the yellow highlighted 4 inside the radical. The I is coming from the negative 1 inside the radical, so we can replace it with I outside the radical. And root 3 stays in because 3 is a prime number. And then 2 is the denominator. You might be thinking, well, that's the end. Yay, I'm done. But you're not. There's one last step, and that is to reduce the common factor. Notice that the common factor would be 2. If we factored out a 2 in the numerator, we'd have negative 1 plus or minus I root 3 all over 2, and we can reduce out that common factor. So my final answers for the two solutions you can't see on the number line or the Cartesian plane are negative 1 plus I root 3 and negative x equals negative 1 minus I root 3. Let's try that again. X is equal to negative b, so the opposite of negative 12 is positive 12, plus or minus the square root of b squared, which is negative 12 squared, minus 4 times a, which is 16, times c, which is 9, all over 2 times a, which is 16. Let's see if we can simplify that further. That will give us 12 plus or minus the square root of 144 minus 576 all over 32. Further simplification gives us 12 plus or minus the square root of negative 432 all divided by 32. Now let's take this 432 off to the side. I know the negative's coming out as an I, so I'm not too worried about that part. But I am worried about how the number 432 would prime factor. I know it's divisible by 2 because the last digit is even, so I'm going to divide out a 2. 400 divided by 2 is 200. 30 divided by 2 is 15, so I have to carry that 5. 2 divided by 2 is 1, so 216 is half of 432. The last digit is still even, so I can divide by 2 again, and I get 108. And this pattern continues. Half of 108 is 54. Half of 54 is 27. Oh, and there's a perfect cube. So 27 divided by 3 is 9. Divided by 3 again is 3. If you haven't seen a division ladder before, welcome to a division ladder. I love this. Saves so much time because all the prime factors are sitting outside, and so if you were to multiply all these prime factors back together again, you would end up right back where you started at 432. This is convenient because we can rewrite these prime factors as exponents. 2 to the 1, 2, 3, 4. 2 to the 4th. 3 to the 1, 2, 3. This is what 432 represents as exponents. So we can write this as 12 plus or minus I root 2 to the 4th, 3 to the 3rd. Now think about this as a fraction. How many times will 2 go into 4 as the exponent? Well, twice. So 2 to the 2nd is 4. You could also group these, and you could say, well, there's 4. There's another 4. 4 times 4 is 16. That's a perfect square. And so I could take 16 out as a 4 outside my square root. So here we go. We're going to take out 4. The I is still there. And then we have 3 to the 3rd, so 9 times 3. 9 is a perfect square of 3. So 4 times 3 is what comes out of the radical, and root 3 remains in. 32 is still my denominator. So now I'm going to rewrite this one more time, hopefully, maybe twice, we'll see. We'll have 12 plus or minus 12i root 3 over 32. Now my common factor is 12, so I'll take 12 out. That will give me 1 plus or minus I root 3 all over 32. Now remember, 32, if we divide by, let's see, 2, that will give me 16. If I divide by 2 again, well, let's just divide by 4. If I divide by 4, I get 4 as a remainder. Think of it like this. We have a 3 times a 4 in the numerator. That will give me my 12. And I also have 2 times 4 times 4 in the denominator. The only thing that's going to divide out of both is a 4. Okay, final answer, I think. We have x is equal to 3 times 1 plus or minus I root 3 all over 8. You could also distribute that 3 back in now that we've reduced out the common factor. Those are my two solutions. You can also write it as 3 plus 3I root 3 over 8 and 3 minus 3I root 3 over 8. Whew, that was a lot. Hopefully that has helped you learn a little bit about radicals, a little bit about ladder division, and a little bit about factoring sums and differences of cubes.